Now let us discuss about the Coulomb's law. So Coulomb's law basically deals with the forces between the charges. The charges are of the same nature, then the forces are of repulsive nature, and if they are of opposite nature, then the forces will be of attractive nature. So as you know, like charges will be repelling and unlike charges will be attracting each other. Now charges are represented by q1 and q2 separated by a distance r. Let both of them be positively charged. So as per Coulomb's law, the force of repulsion in this case between the charges is directly proportional to product of the charges q1 and q2 and inversely proportional to the square of the distance between them. Now this proportionality is changed by a constant 1 by 4 by epsilon 0 q1 q2 by r square. Now what is this epsilon 0? Epsilon 0 is the permittivity of free space. Permittivity of free space, whose value is 8.854 into 10 raised to minus 12. Now this will go here and Newton will come here, so it will become Coulomb squared per Newton meter square. Now what is this physical significance of this permittivity? So it provides, or the permittivity more means the medium provides more hindrance for the electrical force to interact with. So for example, if you take the medium water, the two charges are kept in water, then the equation will turn out to be F is equal to 1 by 4 pi epsilon of water q1 q2 by r square. Now instead of writing the permittivity of the medium directly, we used to represent it by a ratio between the permittivity of the medium to the permittivity of free space, that is epsilon m by epsilon 0, which is represented by a quantity called k or epsilon r. So in this case it is water, so epsilon water by epsilon 0 is equal to k, and k for water is equal to 81. So epsilon of water by epsilon 0 is 81. So what does this signify? It means the permittivity for water is 81 times the permittivity of free space. So it means, so when you substitute in this equation, then the force between the charges when it was in air or vacuum is 81 times or 1 by 81 times less when it is kept in water. So force in water is equal to force in air divided by 81. So as the permittivity of the medium increases, the charges find difficult to interact with. So the hindrance which is provided to the electrical field by the medium is called the permittivity. Now how to represent? Normally the question will be not to write the Coulomb's law. Question will be to write the Coulomb's law in the vector form. Now how to represent Coulomb's law in a vector form? Assume there are two charges as we did q1 and q2. Now since force is a vector quantity, these being two positive charges, obviously he will be repelling the q2. So let the force experienced by q2, force experienced by the second charge due to the first charge, let it represent by a vector, and in which direction it will be acting. So repelling force, it will be acting in this particular direction. So similarly the force experienced by q1 because of q2, so we can write it as force on 1 due to 2, it will be acting in this direction. Now let me draw one position vector representing the direction. So let r vector r 2 1 be the position vector or direction vector which is drawn from 1 to 2. So its direction is in this Similarly, let R21 is there. So let R12 is the position vector from drawn towards 1 from 2. Drawn towards 1 from 2. Now let us represent the vector form of the Coulomb's law. Force on 1 due to 2 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R12 and R21, even though they represent the direction, the magnitude wise it is same. So magnitude of R12 and magnitude of the R21 are same. So let it be represented by R. So you will have 1 by 4 pi epsilon 0 Q1 Q2 by R square, and let R cap 1 2 and R cap 2 1 be the unit vectors directed towards the position vector R12 and R21. So you can represent force on 1 due to 2 is equal to 1 by 4 pi epsilon 0 times Q1 Q2 by R squared. It is directed, see, force on 1 due to 2 is in this particular direction, so it is towards this vector, position vector. So I should represent it by the unit vector pointing in this direction, so R12 cap. Similarly, force on 2 due to 1 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by magnitude R squared pointing in that direction, so R21 cap. In some textbook you can also see, so this is how you represent the Coulomb's law in vector form. In some textbook you can also see something like this: F12 is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R cube and vector R12. So how do we get this? See, unit vector R12 is actually equal to position vector R12 divided by its magnitude. So when you include in place of position vector, unit vector, so you will have R vector 12, this R will be added to this, so it becomes R cube. Similarly, F21 can be written as 1 by 4 pi epsilon 0 Q1 Q2 by R cube R21, vector R21. Just remember, if it is R squared, this is R cap 12. If it is R cube, it is vector R12. Thank you.